Hello and welcome back to my channel. We're going to be looking at some different related rates problems, starting with this one. So a 12-foot ladder is leaning against a wall when it begins to slide down the wall at a rate of 2 feet per second. At what rate is the base of the ladder moving away from the wall when it is 5 feet from the wall? So the first thing I'm going to do is draw a picture. So if I think about what's going on, we have a wall and the ground, and we have a ladder that is on this wall. So what we have here is a right triangle. So the things that it tells me, it's a 12-foot ladder. It begins to slide down the wall at a rate of 2 feet per second. So this side is going down at 2 feet per second. And 5 feet from the wall. So the ladder is 5 feet from the wall is what we're looking at. We want to figure out what this movement is. So some things that we can kind of decide. We are going to label our sides. Generally speaking, with a right triangle, we're going to use A, B, and C. We know that this is going downward, so this side is getting smaller. So this is going to be a negative 2 feet per second. Our ladder here is not going to be changing sides, so the rate that the ladder is changing, dc over dt, is going to equal 0. So currently what we have right now is we have A, B, and C. We don't know what the side length of A is. We may or may not need it. We know B is 5 feet, and we know C is 12 feet. We also know dA over dt is equal to negative 2. We are trying to solve for dB over dt, and dC over dt is equal to 0. So what equation can model this situation? Well, the best equation that we can use for a right triangle, and we're looking at sides, is a squared plus b squared equals c squared. Okay, differentiate the equation from part C with respect to time. So we're going to differentiate the Pythagorean theorem. So we have 2a dA over dt plus 2b dB over dt equals 2c dC over dt. They all have a 2 in common, so I can get rid of that. Okay, so looking at this, I need A, B, C, and then I need the rates of change. So I need to figure out what A is before I can do anything else. So we have A squared plus 5 squared equals 12 squared. So we have 25 and 144. So A squared, we're going to subtract 25 from both sides. 144 minus 25 is going to be 119. There is not really a nice square root of 119, so we're going to just say A is equal to the square root of 119. So we're going to go ahead and plug in all of this information. So I know A is the square root of 119. We also know it's changing at a rate of negative 2. We know B is 5. We are solving for dB over dt. C is 12, and dC over dt is 0. So we have 0 is equal to 5 dB over dt plus negative 2 square root of 119. So we're going to move that square root of 119 and 2 over by adding it to both sides. So 5 dB over dt is equal to 2 square root of 119. And then we need dB over dt by itself, so we're going to divide both sides up by 5. So I have 2 times the square root of 119 divided by 5. Now, when we're thinking about these problems, if I were to just give someone 2 times the square root of 119 divided by 5, that is not a very nice answer. So we also want to think about what that would be as a decimal. And if I put that into a calculator, I'm going to get 4.363. So our last part is, well, solving and answering the problem, which is what we just did. So now the last part is the rate the base of the ladder is moving away from the wall is 4.363 feet per second. when the ladder is 5 feet from the wall. So we're going to look at another one in just a second. Related rates is just about kind of looking at what you have, what you need, and what it kind of relates to.